All right, class, welcome back. So, okay, so the point of kind of going through that exercise isn't necessarily to convince you of one particular political viewpoint or the other. The point is that if you're trying to understand something or if you're trying to make an argument for something, you're going to get a lot more. You're going to get a lot more traction. You're going to progress a lot more if you are armed with something like what I just showed you, something like this, um, that is the result of quantitative analysis, as opposed to if you were just armed with some sort of verbal argument. Okay. And in terms of, advancing our understanding of economics or really any social issue, having access to that kind of data and knowing how to analyze it is is um, is going to be very, very much helpful. Okay. And so, so you might ask, well, what did it take to do all of that stuff, to generate all of the results that I just showed you? And the answer is simple. It takes a couple of thousand lines of computer code. Okay. Now, obviously, you're not going to be these types of models. You're not going to be running them by hand. You're not going to be computing these metrics by hand. It would take you a lifetime to do that. Okay. And so, what you do is you learn to use how to have the computer do the heavy lifting for you. And so, for example, most of the research that I just showed you in that project was done using a programming language, using a statistical package called R. R is a very popular package, but there are many others. You may have heard of some of these: SPSS, Stata, MATLAB, even Python. People are doing a lot of data science in Python these days. Okay, so so part of learning how to do data science is learning how to use this type of software. Now, um, now obviously, over the course of this unit, we're not going to be doing anything quite as advanced as what I just described. Okay, but nonetheless, I wanted to give you a sense of what the field is all about. And because applied microeconomics is such a hands-on subject, I'm going to ask you in a lot of the homework to basically to be working in some kind of spreadsheet software, particularly in Google Sheets. And this is not an optional part of the class, okay, to be working with this software. I want you to learn some of these basic skills because, an understanding of how to use a spreadsheet software is sort of the stepping stone to using any of the other data analysis software that's out there. Okay. Uh, a clarifying point, okay, before we move on. I've used the word applied microeconomics quite a bit in this lecture, but you've also heard me mention two related terms. One is econometrics, and the other is data science. For the purposes of our class moving forward, I'm going to use these three terms somewhat interchangeably. Okay, applied microeconomics, as I've said, is using data to probe microeconomic questions. But, how do you go about doing that? Well, it's using the tools and the methods of something called econometrics. And econometrics is simply the application of statistics to applied microeconomics or to any type of economics. Most people outside of economics would simply call econometrics applied statistics. Okay. And finally, this concept of data science. So data science is sort of a new thing in a way. It's an emerging field. It's a very hot field. In fact, it was out of the hottest careers last year. I think it was ranked number 2 or something like that. But again, it really isn't new in a way. Economists have been doing data science for a very long time. People outside of the field of economics might call applied microeconomics data science. They might just see it as a form of data science. And that's a perfectly valid way of looking at it. Okay, so just some clarifying points. All of these three terms essentially have to do with the analysis of data. And I want to try to convince you guys, if you think that this is something that you might be interested in, that, there's really no better time in history than the present in terms of learning how to work with data and learning how to analyze data. Because Well, you see, I mean, for the whole of human history, okay, there really wasn't a lot of good data to come by. Collecting even basic data about society at any sort of significant scale is an extremely expensive and difficult undertaking. Um, However, that is starting to change. Okay, and to give you a sense of how much this is starting to change, I'll give you guys some figures. Okay, I'll give you guys some rough numbers. So um, it's estimated, okay, that from the dawn of time, from the dawn of human history, all the way to 2005, the human race created something like 130 exabytes of data. Now, I'll put that into perspective for you. How much is an exabyte, you ask? Well, okay, so this is one byte. Okay, so as you guys know, a byte is a way of measuring the amount of information, particularly when it's stored on a computer. Okay, so you guys are probably aware that you have your computer has a certain number of megabytes of memory. It might have a certain number of gigabytes of hard drive space. Okay, so 1 byte isn't a lot of data. 1 byte is essentially one alphanumeric character. Okay. Um, Now, if you think about a kilobyte, that's 1,000 bytes, 1,000 characters. That's about the amount of information contained in one page of a typical book. Okay. So how much is 130 exabytes? Well, we got to kind of scale this up. We got to go up the scale. Okay. So a megabyte, 1 megabyte is roughly the amount of data contained in a single novel. 1,000 kilobytes, 1,000 pages. Okay, that's kind of like a novel, right? If we go up by another factor of 1,000, okay, this you probably heard of. You probably heard of a gigabyte. Okay, a gigabyte is 1,000 megabytes. It's actually the amount of information stored on a compact disc. Okay, not a DVD or a Blu-ray disc, but a regular compact disc for storing music contains about a gigabyte of data. It's also, coincidentally, roughly the amount of information stored in the human genome. Okay, so think about all the information stored in the human genome, in the DNA of a single person. That contains all of the genetic information needed essentially to create and to run, the body of that person. Okay, that's about 1 gigabyte's worth of data. Okay, now this is starting to be, quite a bit of data. If we multiply by another factor of 1,000, then we get a unit known as a petabyte. I'm sorry, a unit known as a terabyte. Petabyte is the next one. So a terabyte's a lot of data. Okay, most computers these days have about a maximum of 1 terabyte of total storage. How much is a terabyte? So imagine, taking an HD webcam, okay, and following a person around and filming them for their entire life. Okay, so you take this HD camera, you follow a person around, film them 24/7 for their entire life. The resulting footage, once it's compressed, is going to be about 1 terabyte. Okay. Okay, so let's keep going. So a petabyte is 1,000 terabytes. Okay, let me show you a picture of what a petabyte looks like.
So on today's episode of Holy Sh**, we have, oh wow, this is really heavy. This is, I'm fairly certain, the most expensive thing I have ever unboxed. This is the Petabyte Project. And what is a petabyte? Well, a petabyte is 1,000 terabytes. 1,000 terabytes of storage. I buy Power and MSI's new lineup of gaming laptops physically. Well, we've got 1 box, then we got 2 boxes, and actually, look at this. There's another box. Inside, I hope I don't break the table. Inside all these boxes are 110 terabyte Seagate Enterprise helium-filled drives, 100 of them. So 100 times 10, for those of you who attended the same math school that I went to, is 800 terabytes. And you'll get that joke a little bit better later. So how do you transport 100 hard drives? I was actually legitimately curious myself because I've never had 100 hard drives delivered to me before. The answer is apparently via couriers that don't even need labels on the outsides of the boxes. These really don't seem like they're doing a lot. I mean, they sprinkled some peanuts on there. Good job. If it's broken, I'll forgive them. Oh. You know what? I am just going all like Tarzan on this thing. There we go. I mean, the thing about hard drives is you pick up one of them off the table, they don't really seem that heavy. You pick up 20 of them, they start to get pretty heavy pretty fast. So we actually probably have to get like each of these boxes open. Now, how did they end up with this random mishmash of packing materials? Let's see how many different types of packing material we can find. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 packing materials. Okay. See, this one all has the same packing material in it. So here it is. This is what's inside. More packing material. I mean, they're hard drives. They're kind of fragile. This all makes sense, but here we go. Oh, yes. So I guess now then is a good opportunity to talk.
Okay, so point being, okay, a petabyte is a lot of data. I mean, who knows? In 10 years, maybe that'll fit in your pocket. But a petabyte's a lot of data, okay? And to get to a exabyte, okay, to get to an exabyte, we need to increase that by yet another order of magnitude, okay? So 1,000 petabytes is 1 exabyte of data. Now, like I said, from the dawn of time to 2005, it's estimated that humans created something like 130 exabytes of data. Now that's everything, okay? That's every word ever spoken, sung, or written. That's every picture ever taken, every movie ever made, every website, every instant message ever sent, up to the year 2005, 130 exabytes, okay? Now, by 2010, this figure had ballooned to 1,200 exabytes. Okay, so it increased by basically a factor of 10. By 2015, it had grown again to almost 8,000 exabytes. And by this year, 2020, this number is expected to reach 40,000 exabytes or 40 zettabytes of data. Okay. And you can imagine why this is, right? Everything that we do these days creates data, right? Every time you click on a link on a web page, every time you participate in social media, all of that stuff is recorded. All of that stuff is data. It's almost as if going through our daily lives, we generate a trail or an exhaust plume of data. Okay. And so, the quantity of data then has been growing exponentially. But here's the thing, only recently are we starting to be able to get a handle of, doing something, making sense of all that data, okay? Certainly the number of people who have the skills to work with all of this data, certainly that hasn't been growing yet nearly as fast of a rate. And so, there's been tremendous demand for people who can basically, look at a data set and understand how to make it tell a story. Okay. So, like I said, though, economists, we've been working with this kind of stuff for the past 50 years, and we've developed many of the methods for doing so. So, moral of the story, there's never been a better time to study applied micro and there's never been a better time to learn some of these skills. Okay, so to that end, as I mentioned earlier, we're gonna be creating a survey. Okay, we're gonna be surveying a class, and we're gonna be surveying our class, try to learn a little bit more about each other, and see what we can do with the data that we collect from our own class. So what I want you to do, this is part of the assignment. Okay, you'll see this when you go on to Top Hat. Is I want you to come up with some creative survey questions about that we can put on this survey. Okay, so what do you want to know about your classmates? Now, so part of your assignment is to come up with at least one question. Okay, and I'll gather up the most interesting questions and I'll put them in the survey. The survey is going to be electronically conducted next week. So there's two guidelines that you have to follow when you're coming up with a question. Okay. Number one, even though the survey is going to be anonymous, don't ask anything too personal, okay? Don't put anything on there that you wouldn't yourself be comfortable answering, okay? That's number one. Number two, and this is very important, the question needs to be multiple choice, okay? So in other words, if you ask people to say, okay, what is your favorite movie? That's not going to be all that useful because we're just going to get 100 different answers, okay? Or if you ask somebody, to describe, say you ask somebody to describe the most significant moment in their life. Well, again, it's hard to answer that in less than a paragraph, and we're just going to have 100 different paragraphs, and it's really going to be hard to work with that data or to do anything with it, okay? So the easiest type of data to work with is a question that is either multiple choice or a numeric answer, okay? So, for example, instead of what's your favorite movie, okay, maybe ask what's your favorite genre of movie out of the following 5 genres, and you can list some genres. Okay. It can also be, I put here that it needs to be multiple choice, but strictly speaking, it doesn't have to be multiple choice. It just has to be answerable in a number. Okay. So either you can do multiple choice, or you can be like, for example, what is your age? Or what is the number of people in your hometown? Okay, so a numerical answer like that, almost like on our homework questions, we tend to have multiple choice questions, and occasionally we'll have like a free response numerical question. So try to make it like that, okay, and submit those questions. That's part of your assignment. Okay, so one final thing, which is that I have, as I mentioned in the last lecture, the exam is scheduled for April 14th. Okay, that's next week, Tuesday. We're going to have it at 4:30 p.m. Okay, I forgot to mention that, but it's going to be at 4:30 p.m. So our regular class time. So I'm going to be posting a study guide along with this set of videos. Okay, so have a look at the questions on the study guide. They're going to be most similar to the questions on the exam. What is the exam going to cover? The exam is going to cover, it's not going to cover this lecture or anything that we do this week, but it is going to cover that whole previous unit on the new micro, and it's going to cover the lectures that we did in the unit on markets subsequent to the first exam. Okay, so have a look at the study guide, and if you have questions about any of the questions in the study guide, then come see me in virtual office hours. Okay, okay, that's it, and I'll see you guys on Thursday.